Hello friends, in this theorem we have to prove that every diagonal element of Hermitian matrix must be real. मतलब Hermitian matrix के जो diagonal के एलिमेंट होंगे वो रियल नंबर होंगे. So first we suppose that let A is equal to Aij be a Hermitian matrix. Therefore, by the definition Aij, this is equal to conjugate of Aj for every I and j. Here we suppose A is the Hermitian matrix, and we know that for Hermitian matrix Aij is equal to the conjugate of Aj. So for diagonal elements, these indices I and j are equal. So in place of j we replace I. So we get here Aii is equal to conjugate of Aii. Let Aii, this is equal to x plus Iy. So Aii conjugate is x minus Iy. Now we put these values in above. We get here x plus Iy, this is equal to x minus Iy. Now we transform this x in the left hand side, this Iy in the right hand side. We get x minus x plus Iy plus Iy, this is equal to 0 plus 0i. So there is 0 plus 2iy is equal to 0 plus 0i. Now equate real and imaginary part. We get here 2y is equal to 0. That means y is equal to 0. Here we can see that y is the imaginary part of Aii. So Aii, this is equal to x plus I into 0. So this is x. So Aii is purely real. Therefore, diagonal element of Hermitian matrix must be real. Thank you.